Okay, so this is me. So if you want to argue with me, that's a good place to do it. I'm not always working on security stuff. I've worked with some really talented people who work in InfoSec, but mainly I work on distributed systems and computer science research. Yeah, this is a little disclaimer that I'm not doing security full time. So in this talk, I'm going to outline what is a threat model. I'm going to review some common attacks that you guys all already know, I hope. And then I'm going to sort of segue into this, this sort of important thing, which is Node's big security gap. And then there's a sort of work in progress proposal that we have. How many people here know what a threat model is? Okay, so no one. Okay, so just really quickly to give you some color. So threat model is about looking at something, how something is used, so we can figure out how we might be able to attack it. So a good example is a car. So we could smash the windows on it. We could take the stuff inside it. We could immobilize it by slashing the tires, and you got to think like a criminal, right? So anyways, this is what threat modeling is about. This is the gist of that. So let's talk about some common attacks to get started. So a lot of you who have been doing stuff with servers probably know about what a man-in-the-middle attack is. And I promise this will get more interesting. But man-in-the-middle attack, basically where we intercept data, we add something that we're not supposed to, and then we're able to get what we want, right? So if you've ever sat at a cafe and you've used some kind of public internet, especially in New York, you may have noticed that if you were viewing source, there was some code in there that doesn't look like it was intentional, or maybe it was just full of trackers, and your little snitch application window is going crazy because it's trying to talk to 300 different domains. Telcos inject trackers and all kinds of things when you're not using an encrypted transport protocol. There's a fun little toy at MITMproxy.org where you can experiment with injecting content and man-in-the-middling yourself. Okay, so another attack that most people in this room probably are familiar with, especially if they're working on front end, right? Is okay. So an attacker looks at how long the latency is when they're passing data to a function in order to determine if maybe there's some correctness to the input. And this is a really well-known attack, timing attack, side channel attack, where the mitigation to this is pretty well known, right? So you pad your functions. You make sure that they always return after the same amount of time so that it's difficult in order for someone to determine if their inputs are correct or not. And there's a really good article explaining this in real detail down to the whole optimization naivety in implementing by a guy that works on V8 named Matthias. Another really well-known attack, a distributed denial of service attack. And you probably, if you're working at a bigger company, you've probably been attacked like this before. As soon as anything kind of becomes interesting or high profile enough, there's attacks that start to happen eventually. Every time you see people on Twitter saying, GitHub is down, it's probably because they were DDoSed. And there's a really obvious solution to this, which is rate limiting, although it doesn't always work, but rate limiting and at the user and IP level. Again, a really well-known solution to a well-known problem, right? And then, if anyone isn't familiar with OWASP.org, they should go to it. You should go to it, and you should look at it because there is a whole world of information. You could start a career in InfoSec just by reading this website. So now, kind of getting into some more interesting stuff. which is more relevant, and we're segueing into this security gap that I'm talking about. So something can be secure, but then the way that you use it can make it really insecure, right? Like a knife is it's a perfect instrument. But if you give it to a child, then, or sometimes if you give one to an adult, then you've got a problem. So NPX is one of these really kind of interesting problems. I've seen some people do some really wild and totally inappropriate things with it. If you can persuade a user to do something with code, you've essentially done the same thing as emailing somebody a nice shiny invitation to a fortune that their distant relative has left for them, but it's unclaimed. And if you only send them some money, then they'll send it right to you. They'll deposit the money in your bank account. Basically, like remote code execution is sort of the new phishing for developers, because developers are holding all these keys, all of you probably have some really sensitive stuff on your computers, and that makes you really interesting targets for people. And you're starting to become it's starting to become more and more clear that you guys are the target. So there is a well-known solution to this. That's auditing and dependency deep freezing. But there's a bit of a problem with this, which is that probably who in this room has audited a module? And who in this room has audited all the way through their dependency tree? No one, except for Matteo. Because you contribute to half the modules, or more, almost all of them. Okay, so so beware of NPX, because it's a potentially incredibly dangerous tool. But that's not the message here. The browser has to deal with this idea all the time. The browser sort of has this idea that, okay, I'm going to have to deal in my daily life with interpreting and running untrusted code. So people in the browser, they've been faced with this problem for a long time, and so they have thought of some really good ideas for mitigating this problem. And so probably everybody here who, especially if you've done front end, you're well aware of what a cross-site scripting attack is. And so just to illustrate, oh, look at that pointer. Okay, so just to illustrate, if I put some data into a database and it isn't escaped properly, then it's obviously really easy to break out of the intended container and to do things that are essentially unintended behaviors. And so the mitigation to this is a content security policy. And this is starting to get really close to what I actually want to get at. By the way, if you don't know about content security policy, bookmark this. So the content security policy is actually really, really amazing. And so it's this great thing where we can essentially whitelist things that an application should be able to do when the application runs. So all the things you do at design time are all the things that can happen at runtime. And if any of those things if there's any unintended behaviors, the result is an error, right? And so CSPs are actually really easy to implement. All you really need to do is add some nice declarative and pretty confusing blob of meta string to your HTML with this weird cryptic syntax here. You can also serve a header with that weird cryptic syntax. It's not that weird. There's a pretty well-defined definition for the grammar of content security policy. But I don't know about you guys, but I was like, what is this when I first started looking at it? How many people here use a content security policy? Okay, almost no one. Okay, right. Well, that makes sense. So Chrome collects usage data, and they have this really lovely website I think it's chromium.com/features/usage, and we're able to know the actual usage of certain features in the browser. So there's like millions and millions of requests that get sent to this, and then we get to know who's using what features. And so CSPs are almost not used by anybody. And if they are, they're used incredibly liberally. So as you saw back here, there's some ways that you can sort of define like what sort of things should be allowed to happen at runtime. And a bunch of those things can be pretty liberal. Say, for example, I want my image, I want my styles to be able to come from anywhere. Maybe I don't add a nonce to them. Maybe I don't have a hash for them. Maybe I use this very liberally, and that's what we're seeing with the usage statistics, is that although this really cool thing exists, no one is using it. And so the question is why? Well, this is true to pretty much any kind of security mechanism, is if people aren't able to understand it, no one's going to use it. And so this is something that a lot of security people are just constantly trying to figure out, is like, well, how do we get people to use this thing? And unfortunately, a lot of security people don't really understand developer experience, and they certainly don't understand user experience. And so there's a big disconnect there, and I think that's why a lot of security solutions end up feeling pretty cryptic once they get to people like yourselves. So that's a gap. But the main thing here about why people aren't using this is because of the fact that it breaks a lot of things. So if you're using React, for example, I'm pretty sure that React is still broken when you add a CSP. Maybe somebody out there could correct me, but there's a lot of frameworks that actually break when you add CSP to them. And there's a lot of code where people assumed, hey, I should just be able to throw some inline styles into there. And probably most of those people don't realize that that's an attack vector, and that you can severely compromise. I mean, you could get root system access to a server because of that. And so there's a lot of vulnerabilities, and we don't really feel like patching them because they break our code, right? So why should we use CSPs? There's a lot of value, but we don't. So the current state of things is that there are really well-known solutions to attacks that are well-known, right? So we know what the problems are, we know how to fix them, but the exception to that is that we're running a ton of unaudited code. Like most people here didn't put up their hand when they said that they were auditing their code. Node programs also, because of, hey, small modules. We have these really big dependency graphs, and there's been a bunch of different attempts to create commercial solutions, and they haven't really panned out that well. It doesn't really fit that well into the FOSS free open source model. So there's also these really kind of heavy sort of sandboxing solutions, like, I could spin up a virtual box, and I could have an operating system in my operating system so I can run some code. And this kind of breaks down to, it just destroys the sort of local development experience. So not many people are using that solution to sandbox themselves from situations where they want to run arbitrary, unaudited code. So the reason why everybody should really give a shit about this right now is because we're seeing bad actors more and more frequently, right? We're starting to see, everybody knows about Dominic Tarr's module, event source, and then I think it was yesterday or the day before, there was a NPM blog headline that says $13 million saved by, I think it was Adam Baldwin or somebody who had found Electron Native Notify, which was attempting to call home and deliver some wallet information for a crypto wallet or something like that. Anyways, the point is, we're starting to see more and more threats from this particular type of attack because we're running untrusted code and we hold a lot of keys. So you're a target. But maybe there is something that we can do. Maybe we can create a solution. Maybe the solution is to borrow from some of these really great ideas in CSP. Maybe CSP isn't exactly what we want, but maybe there's some things that we can borrow from it. It would definitely have to be something that we could opt into because we don't want to break the world, right? But we do want something like this because it's a really close analog, right? We're running dynamic code. It's untrusted. And the Chromium project itself is a really good example of how this can work. And if you dive into the Chromium code base, which is pretty significant endeavor, but if you decided to do that, you would find that they've actually spent a lot of time trying to figure out how to make a sandboxing solution that's cross-platform. And this is actually probably some of the best work in this space in terms of trying to understand a good analogy to something like Node. How would we run cross-platform a runtime that leveraged the system's native APIs? And so there's this other side of that, which is, has anyone here used Little Snitch? Okay, a few people. What it is essentially, it's a thing that, it's a kernel module with a UI, and what it does is that anytime there's a request to any kind of network resource, you get this nice dialog, and the dialog says, hey, this like web browser or this desktop app or Python wants to connect to this resource. And it tells you what the resource is, what the payload is, all this stuff. And then you can say either no, yes or no. If you say no, then it blocks it. It's not able to communicate. That's pretty cool. That's a kind of a nice user experience. It's like, as a user, I'm giving permission for this process to actually communicate with the rest of the world. That's pretty awesome. And so maybe there's an opportunity for us to also take some ideas from that, because we've seen this in the browser already. The browser is asking us if we want things like audio, right? Maybe when I go to a website, I don't want to be blasted with some song that I don't like, or some advertisement or something like that. And so Chrome said, oh, okay. We'll put something, we'll put a dialogue between you and that. And that's fair. That makes sense. You don't want to be inundated with things you didn't ask for. So, getting more concrete, the algorithm that we're looking at for this solution is essentially where the process that you start up, so if you type node, and then you write a script, what happens is node would look for a policy.json file. And it would look in the current working directory, and then it would traverse up the file system tree until it found one, kind of like a RC file or configuration file in Unix. And then if it does find one, it would look at that as a policy. And it would start in what we would call a restricted operating mode. And so that would mean that Node would start with 0 access to syscalls. Do people here know what a system call is? Okay, cool. Actually, a bunch of people. Okay, yes. So we want to restrict Node as a process from accessing those system calls. So then what would happen is after it started in this restricted mode, it would hash, first of all, as a resource integrity, it would hash the code that it's about to run, and then it would try to match that with the integrity hash that it had. And then if those don't match, then the process terminates. If the computed hash does match, then it sort of moves on to figuring out, okay, well, what kind of entitlements were proposed in the package.json? And then so Node would only permit those system calls to actually happen that were proposed entitlements in the package.json. And then if a process violates those entitlements, then it would be immediately terminated with the proper exit code. And there would probably be, well, we're sort of trying to work on integrating the operating system with this, but there would be also a sort of, not a silent mode, but a non-interactive mode where you would be able to run the same policy check on a server without a user actually interacting with it. So we've been talking about this algorithm for a while, and we've been tinkering with implementing it, and there's been a bunch of work that's gone into trying to make this a zero-cost abstraction, because there's always a trade-off. If you want some security, you're going to have to trade it off for something else. I think it's the Arch Linux wiki on security starts off saying this really sensible thing, which says you can lock a system down until you can't do anything with it. It'll be 100% secure. It'll do nothing. And so what this is about is trade-offs, right? So we sacrifice a tiny bit of performance, but we're trying to figure out a way to make that as small as possible, and perhaps even a zero-cost abstraction. So the most important thing is, what does Fedora think? So he likes it. And then maybe something else that's kind of important. It's just that starting to have a sort of public dialogue about this idea more and more. So I wish that I gave this talk in 2014 or something like that. I can't remember when the first or second NodeConf was. Was it 2012, 2013, something like that? Because by now we would have something really good. So we're starting off with something that's maybe okay. We're going to have to iterate on this a lot. But anyways, we're starting to get a conversation going about this. So what does it actually look like? What did I actually show these people? So so you start off with, like I said, this restricted operating mode. And it's just a JSON file. It should be pretty simple. If for those of you who know what a system call is, obviously there's a lot of system calls, and trying to pack that all into a JSON file where you had to articulate which things were allowed could be kind of a task. And a lot of these things only make sense to use in concert. And so there has to be a second level of abstraction, which is that we make it a little bit more user-friendly and say, okay, well, file system reads. That's going to be a number of syscalls. And it also has to be something that's easy to understand, right? Because like I said before, if no one understands how your solution works, no one's going to use it. So so when we're looking at something like this, this might be an example. This is like the working example right now of basically taking a SHA hash of your dependency tree, and then having a few entitlements, right? And actually, the next slide here we have a little bit better descriptions of this. So, so essentially, FS would be a whitelist. These are things that you can do with a file system. Operating systems are already starting to implement really sort of similar things for user experience. So, right today, if you're on, for example, Mac OS, if you're on Darwin, what'll happen is if you create a node program that traverses your entire file system, you'll notice some weird pop-ups. There's a dialog that pops up that says, this process is trying to access your photos directory. Do you want to allow this? You can actually say no to it, and the process will just hang. That's not a very good user experience, but that's what's happening, is that Apple is starting to implement these, or starting to create a user experience on top of these sandbox APIs that they've got in the operating system. And so that's essentially what we're doing here, is we're starting to abstract the platform's APIs. And so this actually, there's a lot going on each of these platforms. So on Linux, we've got a lot of servers out there, node servers running on Linux, and we want to have some kind of integrity that says when these things run, they should be doing only what I tell them that they should have done. If I have a process running on a server that starts talking to some other endpoint that I don't even know about, telling it, giving it maybe information, maybe I have a miner on my computer, mining crypto, and that wasn't the intended behavior, so I want the process to terminate. Maybe I want to tell AWS that this happened, and then I want to kind of go into some sort of mode. So anyway, yeah, Linux is the only prototype that we've got going so far for this, but libseccomp is really mature, and it's really easy to sort of see what this would look like. And so what this is doing really is it's actually taking this JSON, it's boiling it down to, hey, if this is a sort of a network request, right, with read and write, we take all of the syscalls that are that would be required for that, and then whitelist them with the appropriate parameters, and then pass that to these native platform APIs. So one of the things that I wanted to say is that, well, who is on Windows? Oh, wow, almost no one. OK, well, that makes sense. I want to say that I really like the direction Microsoft's going, and I hope that they do something really cool, like just make a really great theme for GNOME or something. Just put that out there, because I would totally buy their hardware or whatever. They've got that really cool laptop that's almost like a Mac, except it's got a hairy keyboard. It's weird, but they're getting there. Anyways, I don't know a lot about that ecosystem, and if anybody has any interest in this, and I'm sort of giving you a hard time, but there's some really great stuff that comes out of the Microsoft ecosystem, and if you know anything about this, I would love to talk to you. I would be super interested in it. And thanks for being a good sport about my giving you a hard time. So the current approach to this is basically at that very point before any scripts are actually loaded into the node runtime, kind of right at the very beginning, before main actually, before anything happens, we take a look at the hash from this JSON file, and then hash the file tree, and then do possibly some caching so that it's only an expense that you pay the first time. We haven't done that yet, but we've been talking about it. And then before the runtime actually runs any code, we call the platform API to establish that, hey, these are the syscalls we want to do. And then we take each function that would normally access a syscall, like make directory or something like that, and we would wrap that in a function so that it could check to see, is this entitlement allowed? And if that entitlement was allowed, it would go ahead, and that would be a no-op. But if it was a violation, then the process would terminate with the appropriate error code. So yeah, I mean, this isn't a by any means like 100% thought through the right way. There could totally be different ways to do this. And again, if anybody has any ideas or wants to collaborate on this, I would love to work with you on it. So yeah, so I kind of went through that a little faster than I thought, and so that gives me 5 minutes to actually do Q&A. Is that okay? Cool. All right, he's giving me the thumbs up. He says that's fine. Okay, so. And that was actually what I really wanted, because I know there's a lot of smart people here who are working on really interesting things that use Node, and you're clearly a target of somebody somewhere, and you're definitely running untrusted, unaudited code. So give me some questions. I see somebody with a hand up over there. I think that they're tattooed.
Yes. Are there any other ecosystems that have something similar? Like, is this
Yeah, so the closest to analog really is Chrome. It's running dynamic code, it's running untrusted code, and it's trying to do it cross-platform. And that's really the kind of best example we have to go off of. I think generally security is an afterthought. People think about it once there's been a breach, and then they're sort of sitting there going like, what do we do? And so security is rarely preemptive. And so, with Node, I think, let's get ahead of the curve and let's have something that is a working solution. Python doesn't, not that I'm aware of. There's static analysis for other languages. Like for C++, for Vala, there's a bunch of languages that have really good static analysis that can tell you if there's potential security problems. But in the dynamic language world, we don't really have something that can facilitate that, or does, other than, like I said, Chromium project, as far as I'm aware. Yeah. No, not you. No, I'm just kidding. Go ahead.
Wait 1 sec. We have a mic for the questionnaires.
I have 2 questions actually.
Okay.
Yeah, this is an example of a DDoS attack. I'm just gonna and a man, DDoS and man in the middle at the same time. Just gonna no. Anyways, I have 2 questions. One is in the security policy. How do you handle, since Node has all these like local dependencies and everything is very non-globally installed? How do you handle dynamic arguments? Like, you know, no applications will write to their own folder or something like that. Is there?
Yeah. So I think that that's a security violation. Like, if your practice is to say, you know, when you're a module that gets run and you decide, hey, I'm going to write data to my own folder where I was installed, that's number one. That's a bad practice. And you should be writing to a data directory where the user has sort of consented to it. And I think that that's kind of one of the things that we're just gonna see. That, like, for example, like if you're using eval in a CSP, your framework or whatever, your code will probably break. And that's just one of those like sort of trade-offs that we have to recognize is going to happen at one point. Is like, if you're doing weird things, your code will probably break. But I think that that's a fair trade-off.
Okay. And second one is, can dependencies, like if a module does some I/O, can it publish its own policy to JSON, and then the main policy takes that into effect also, kind of like a union of the two, if that makes sense?
Like, if I understand correctly, it's like, can code at runtime modify?
No, more like if I have a dependency that's, you know, reading a file or something internally, but I want to log it down because I know exactly what it's reading, I would like to publish a security policy with my module to VM.
Yes. Ideally, what would happen is it would be like a sort of kind of like inheritance type of thing, where like the stuff in my module tree in my dependency tree would also get sort of added up, and then at the end the user would be asked, "Hey, this is ready to fly. Like, do you accept the terms?" Okay. Right? Yeah.
Thanks.
Yeah.
That's all my questions.
Oh, Matteo.
Oh, sorry.
So,
the guy with the beard and the hair. Yes.
No beard, no hair. So
It's fake?
No, it's not fake. Come on. It's all natural. So the reason I'm both Matthias and myself and Dave, we are huge fans of new function. We use it more or less in places where it's okay to be used.
Yeah.
And so, yeah, what was Matthias was talking about, like having that mechanism where get the terms would be pretty much.
I think that gets was that the question?
No, so the question is, are you planning to allow this type of granularity per package, per file, or something like that?
Definitely. Like, one of the examples I had right here was with eval true. So I think that there may be a couple of different ways to qualify or to quantify like what is eval, right? Because there is function body, right? Like, you want to be able to take a string of some code, you want to evaluate it, and then you want that to become a part of a function that's used in a bunch of different places. Yeah, and I think that CSPs are a pretty good example of how to handle this. They do allow various degrees of dynamic code to be evaluated, and there's like unsafe, right? But then there's unsafe. There's variations of unsafe, and I think that especially in the context of well, let's say we're running a server, and your server does some performance stuff, or maybe some some I don't know. You may have a use case for it. But I think that is an exception where it's reasonable to put into the policy that the level of evaluatable runtime evaluatable code.
Yeah.
Thank you.
Because VM, there's also VM compile function. So you would have, if you set VM parameters, that could conflict with eval because compile function is actually evaling.
Yeah.
essentially.
Totally. I think that we can detect when the VM function is going to start to do its thing, and I'm pretty familiar with that module. So, so we can differentiate between eval and VM, and I think that you should be able to distinguish those things. You should be able to say, well, I want to use this, and especially in the case of the end user, like I'm a front-end developer who is using a CSS tool or using a cool, just something shiny I found, I should be able to say, hey, this thing should not be talking to malware.com. And in that case, that's where this really wins, because it protects all the people who are doing, running these tools and running these shiny new things that they see, because Node has a culture of like building these beautiful things and tons of free software, lots of cool things are being built all the time, especially by creative people. And so we see these shiny things, we want to use them. This is a case where I think this saves us a lot. I think on the server it becomes a little bit more of a nuanced thing. It's like, should we allow this evaluation to happen? Should we prevent that? And so it's something that you would opt into as the person running that process. And you would probably know better because you're running a server. You're going to say more granularly, this is the stuff I really care about, and I'm willing to accept the risk in certain areas.
Is there
I think that was my time.
Can I sneak one in?
One more.
I have a quick one. Kind of like related to what Matteo said. Have you thought at all about like trusted offers in this model? Like, I probably want to, given that I know Matteo personally, if he has signed a module, I want to give more lax permissions to that than some unknown offer.
Yeah, I really like that idea, but I think that goes outside of the scope of this. I think one of the things that we really need to do is make sure that we offer a very low-level, very single-purpose primitive that that people can build around. Right. I think if we offer too many high-level types of things, then it starts to become, that people have differences in opinion about how it should work. And I think if we offer the smallest unit of solution for this, I think it works. But yeah. So, thank you.